We're going to graph and find all pertinent information for two problems for graphing rational functions. A couple of problems from in class. So I'm going to factor r of x. So I'll factor out the numerator, the 2. So I have x squared plus 2x minus 3. Then I'll factor the denominator to x plus 4 times x minus 3. Then I'll further factor the numerator to be x plus 3, x minus 1. So I have enough information to start getting a lot of things. I have no holes, so no removable discontinuities. I have an x-intercept at -3, 0, and 1, 0 from up here. Then a y-intercept if I sub in 0 for all of these x values. In the original version of this, it's pretty easy to see that the y-intercept is 0, 1 half. There is a vertical asymptote at x equals -4 and x equals 3. That's from the denominator. Horizontal asymptote is going to be y equals 2. And I know that because the powers of the top and bottom are the same. So then I just divide the leading coefficients. That means that the limit as x approaches infinity of r of x is going to be 2. Then I don't have an oblique asymptote because I never have a horizontal and oblique asymptote in the same problem. Then the last thing I have to do before I start graphing is figure out the point of intersection of the horizontal asymptote. And I can do that, if there is one, by setting the function 2x squared plus 4x minus 6 over x squared plus x minus 12, setting that function equal to 2. The reason that I want to do the original one is I would have to distribute this out anyway in order to solve it, so I might as well just use the original rather than the factored form. So I'm going to multiply x squared plus x minus 12 over to the other side. So I have 2x squared plus 4x minus 6 equals 2x squared plus 2x minus 24. Then I subtract 2x squared from both sides. They go away. 4x minus 2x gives me 2x, and then I add 6 over to the right side. I get -18, so x equals -9. So that means that the point -9, 2 is where we cross the horizontal asymptote. So I'm going to start plotting some points. And some asymptotes. So I know at -3, 0, 1, 0, and 0, 1 half, I have points on the graph. I have vertical asymptotes at -4 and 3, and a horizontal asymptote at y equals 2. Then I also know that I have a value of the graph at -9, 2. So now the most difficult part for some people is figuring out how to graph this. In this particular problem, I'm going to start in the middle of the graph because I know that since these are not squareds, that means that it's going to cross at these values and not bounce. So that means at -3 and 1, it's going to cross. I also know that I have this value at 0, 1 half, and that it does not cross the horizontal asymptote inside of the two vertical asymptotes. It only crosses over here. So that means my graph has to look something like this. And it is really hard to try and draw this on the smartboard with the lag that I have. But it looks something like this. So it stays in between these asymptotes. This actually is going to kind of go down. It's going to stay in between the asymptotes. It crosses at these 2 points, and it hits 0, 1 half. Then I know that because these denominator factors are not squared, because I know that those aren't squared, that means that since this one goes down at this asymptote, this one has to be coming from above. Likewise over here, since this one goes down, This one has to be coming from the top. If they were not squared, or I'm sorry, if they were squared, then they would be approaching from the same side. And that's something that we learned in Algebra 2, and we've kind of talked about it again this year. So that means that these are both going to start up here. On the right side, it never crosses the horizontal asymptote. On the left side, it crosses at -9, 2, and then starts to come back up. So this is what my graph looks like. This one, I'm going to factor the denominator. So I have x minus 1 squared times x plus 2 over x minus 1, x plus 1. And what ends up happening is that one of these can cancel out. So I have x minus 1, x plus 2 over x plus 1. I have an x-intercept at -2, but the one at 1, 0 is actually not an x-intercept. That is a hole because I had 1 cancel off. It is not in my domain. The y-intercept, if I plug in 0 for everything, I get -2 over, I get 2 over -1. So that's 0, -2 for my y-intercept. I have a vertical asymptote at x equals -1. I have no horizontal asymptote because if you notice, the power in the numerator is greater than the power in the denominator. So I'm going to have to do long division to find the oblique asymptote. So in order to do that, I'm going to multiply the numerator out. That's x squared plus x minus 2. And then the denominator is x plus 1. So I'm going to do some long division. And I end up getting x. And then I multiply this out. I get x squared plus x. And that works out pretty nice because when I change the signs, that goes away. And then I have -2. So if I divided this out, I would get x minus 2 over x plus 1. This is my remainder. And this part before the remainder is going to be my my oblique asymptote. So y equals x is the oblique asymptote. And then if I check the remainder, -2 over x plus 1, that will never equal 0 because I can't make the numerator equal to 0. And if the denominator is equal to 0, that's undefined, not 0. So therefore, there is no such place where I cross the oblique asymptote in this problem. And then if I look at this, the function value is going to infinity. If x goes to infinity, this looks like it's going to 0, but it never actually hits 0. It has a hole there. And then this one, as you'll see when I graph it, is -infinity. So I'm going to now start graphing these things. So I have the line y equals x and the line x equals -1 as my asymptotes. I know that I have a hole at 1, 0. I know that I have 0, -2, and -2, 0 as points on my graph. And then after that, it's pretty straightforward because I never cross the oblique asymptote. I know how to make something that kind of looks like the shape of my graph. And once again, I kind of skimmed over it, but as I approach -1 from the right, so if I approach it from the right, that's over on this side, that means I'm going down toward -infinity.